Hi all, welcome to the section 10.3 lecture video. This will be our last lecture video with new material for chapter 10, and then the last section is a putting it all together section like we had for chapter 9. So here we go. Go ahead and take out your chapter 10 handout, which once again can be found under handouts on my math lab, and turn to page 14 to get started with this section 10.3. So in section 10.3, we're going to do fairly similar to what we did in section 10.2, which is take what we know about how to do hypothesis and do them for the mean. So in order to do a hypothesis test for the population mean, two things have to be true. The sample has to be obtained using simple random sampling, and the sample can have no outliers, and the population from which the sample is drawn is normal, or the sample size is large enough and has to be greater than or equal to 30. In that case, it's going to work a lot like it did for section 10.2. So you're going to write your hypotheses. You're going to determine your level of significance. You're going to compute the test statistic, which will be the t in your ClassCalc app when we run the hypothesis test. It is also equal to t equals x bar minus mu over over s divided by the square root of n. Okay, so that's the idea. Then we can use the table 6 to estimate the p-value using n minus 1 degrees of freedom. That's not what we're actually going to do. What we're actually going to use is ClassCalc or StatCrunch, depending on the situation, and we'll look at both of those here today. If the p-value is less than alpha, we reject the null hypothesis, and then we state the conclusion. Once again, like in section 10.2, just to save on time, we're going to skip over the classical approach, which really isn't used that much anymore anyway. So I'm going to skip over these couple pages and get right into using the calculator to do these tests. So once again, we have the rules for using the graphing calculator. If you want to use those, feel free, but we're not going to use them because we're going to use ClassCalc. So in ClassCalc, this is very similar to what we did for either doing t intervals or for doing one prop z test. We're going to use ClassCalc, and we're using the t distribution again because we're doing the mean, which is what we learned about in chapters 8 and 9. So if we go to the ClassCalc app, what we're going to do is we're going to go to stat, tests, and then we're wanting to do a t-test. So we use t-interval to do confidence intervals with this stuff, so we're going to use t-test to do the test. And so what we need our mu value, our sample mean, our sample standard deviation, and our sample size. Okay, so you're going to go to, you're going to use the t-test, and when you do that, it'll on the calculator, it'll say t-test, and then it's going to want your mu value, x bar, s, and n. So let's look at an example. So according to the American Time Use Survey, the typical American spends 154.8 minutes or 2.58 hours per day watching television. Do internet users spend less time each day watching television? A survey of 50 internet users results in a mean time watching television per day of 128.7 minutes with a standard deviation of 46.5 minutes. Conduct the appropriate test to determine if internet users spend less time watching TV with a significance level of 0.05. So first of all, we can do a hypothesis test because our sample size is greater than or equal to 30. So we're going to go ahead and write our hypotheses. So our first hypothesis is that mu equals 154.8, so that it's the same as a typical American. And then H1 is going to be that mu is less than 154.8 because it tells us we want to look for less time watching. So then we can use our t-test, and we're going to plug in our mu, which is 154.8, our x bar, which is our sample mean, So that's 128.7, our sample standard deviation of 46.5, and our sample size of 50. So 154.8, 128.7, 46.5, and 50. And just like with the one prop z, it gives us the test statistic, and then it gives us the three different test values. So in this case, we're doing less than, so that's going to be this 0.0001. So our p-value is 0.0001. And since that's less than alpha, just like in the last section, we're going to reject H naught, and then we can write a conclusion. So we could write, there is sufficient evidence to suggest the alternative hypothesis, which is to suggest that internet users watch less TV than the typical American on average. Okay, and so that's the idea. Okay, so that's exactly what we can do for all of these where we are not given data, where instead we're given the statistics. So a Fair Isaac Corporation FICO score is used by credit agencies to assess the creditworthiness of individuals. Its value ranges from 300 to 850. An individual with a FICO score over 700 is considered to be a quality credit risk. According to Fair Isaac Corporation, the mean FICO score is 703.5. A credit analyst wondered whether high-income individuals' incomes in excess of $100,000 per year had higher credit scores. He obtained a random sample of 40 high-income individuals and found that the sample mean credit score to be 714.2 with a standard deviation of 83.2. Conduct the appropriate test to determine if high-income individuals have higher FICO scores at the alpha equals 0.05 level of significance. So, what we can tell from this is we can once again do a t-test because our sample size is greater than or equal to 40. So we're going to do H naught is mu equals the population mean, which is 703.5. And then H1 is mu greater than 703.5 because he wants to know if they have higher credit scores. So then we can do a t-test. And we're going to put in the mu, the population mean, which is 703.5, the sample mean, x bar, which is 714.2, the sample standard deviation, and the sample size. So we can just put that into the one we already have here. So 703.5, comma, 714.2, $83.2, and 40. And so in this case, we're looking for greater than, so that's the one on the bottom left, so that's 0.2105. So P equals 0.2105. That is not less than alpha, so we do not reject H naught, and so therefore there is not sufficient evidence to suggest high earners have higher credit scores. Okay, so there's the idea of how to use the t-test in ClassCalc to do hypothesis testing. So now, we can also, similar to what we did, one of the things that is different with the mean is we can use population data. So we can use some tables to do this. Now, if you look in ClassCalc, you first should notice that one of the options when you go to do this is to choose data. And if you want to do that, all you have to do is put in your mean and then list out your data. So like if my mean was 5 and my data was 4 and 3 and 5 and 6 and 8, although that didn't really work. Okay, it'll calculate these values for me just like before. So I could do that in the calculator just like that. However, most of the time you guys are going to be doing this online on your homework so StatCrunch is going to be the way to go. So I went ahead and I put this data into StatCrunch. Okay, so it's right here, listed under golf balls. And so there's a couple things we need to do. So first of all, the U.S. Golf Association requires that golf balls have a diameter of 1.68 inches. To determine if MaxFly XS golf ball conforms to the USGA standards, a random sample of MaxFly XS golf balls was selected. Their diameters are shown in the table. So we could start out real quick by writing our hypotheses. So H0 is that mu equals 1.68, and H1 is that they're different than 1.68 because they have to conform to that standard. So if they're not equal to that, that would be not conforming to the standard. So it says, because sample size is small, the engineer must verify that the diameter is normally distributed and the sample does not contain any outliers. So remember, the way we did, what this is going to mean is we're going to need to do a QQ plot, right? We did that in StatCrunch before, and we're going to need to do a box plot because those are the two things. This one checks for normality. This one checks for outliers. And those are both things we've done in my math lab before. I mean, in StatCrunch before, but let's go ahead and run through them here. So if I do the QQ plot, I've got my data in this first column here. So I'm going to choose graph, and then I want to do a QQ plot, and I want to select my data, which is in golf balls. And then I want to know what is the normal quantiles on the y-axis. Okay, so I want to know, is this normal? So if I hit compute, we can see that that's fairly linear. Okay, not exactly linear, but close enough. Okay, and then I did that one. So now we want to do another graph. We want to do the box plot. So just click graph menu, choose box plot. You want to do the golf balls. We've done this all before. You want to make sure use fences to identify outliers is marked. We did this back in chapter 3. So just if you want to look back at that, you can. And then the one other thing we might want to do, well, that'll work. Okay. So then I hit compute, and there's my box plot. And because I don't see any dots, I know there are no outliers, right? Because dots beyond these whiskers are the outliers. Okay. So these confirm that this was approximately linear. So that's good. And this had no outliers. So that's good. So now we can do the test. So to do the test, we go into StatCrunch. We choose stat. We choose T-stats. We choose one sample, and we choose with data. Now, if you remember from the confidence interval section on the mean, those steps were exactly the same as that. So we're doing exactly the same steps to do the hypothesis test. So then I choose the column I want, and the only thing that's different here is I choose hypothesis test for mu equals 0 instead of confidence interval for mu. So I use my hypothesis test, and I put in my values here. So my mu was equal to 1.68, exactly like I have it written in my class, and then I need to choose the correct inequality, and in this case, it is not equal to. And then I can hit compute, and it gives me a p-value, which is what I care about, of 0.4529. 0.4529. So we got a p-value of 0.454259, which is not less than alpha, which means we do not reject H0, and we can say there is not sufficient evidence to suggest the balls do not meet the standard. Okay, and so that's the idea of doing a data set in ClassCalc. In StatCrunch. So when you have a data set in your homework, click the option to open it into StatCrunch and go through those steps to do the hypothesis test. Then the last thing here in this section is very similar to something we did in 10.2, which is that you can do hypothesis tests when you're doing not equal to using confidence intervals. Okay? So, for example, in 2002, the mean age of an inmate on death row was 40.7 years, according to the data obtained from the U.S. Justice Department. A sociologist wondered whether the mean age of a death row inmate had changed since then. She randomly selects 32 death row inmates and finds that their mean age is 38.9 years, with a standard deviation of 0.96. Construct a 95% confidence interval about that mean age. What does this interval imply? So, we have a big enough sample size so we can do what we're about to do, which is a hypothesis test using t intervals. So we state our hypothesis, which in this case is that mu equals 40.7 because that's the population data. And we think it's gone down. We think it's different now. So mu does not equal 40.7. And so now what we can do is construct a confidence interval around our data set. So in StatCrunch, remember, we're going to choose a t interval for this. So stat, test, and t interval. And then you need to put an x bar, s, and n, and a c level. Okay, so we're going to do t interval. Our x is 38, bar is 38.9. Our standard deviation is 9.6. Our n is 32. And our confidence level is 0.95. So 38.9, comma 9.6, comma 32, comma 0.995. And we can see that we get a confidence interval of 35.4 to 42.4. And so because our mean 40.7 is in our confidence interval, we do not reject H naught. And therefore, we can say that there is not sufficient evidence to suggest that the mean age has changed. Okay. So if at this point you want to pause the video for a moment and try this second one on your own, feel free to do so. And then when you hit play again, we'll go through it together. Okay, so here we go. So H naught in this case would be, we're talking about mean household expenditure. So our mu equals 1,493. And then H1 is that it no longer equals that. Okay, and then we can build a confidence interval because we have enough households in our sample. So we're going to do a t interval with our mean in our sample, which is 1618. Our standard deviation is 321. Our sample size is 35, and we're doing a 95% confidence interval, so 0.95. Okay. So 1618 for our sample mean. Our sample standard deviation is 321. Our sample size is 35, and our confidence level is 0.95. And so we get a confidence interval of 1508 to 1728. So because our mean is not in our confidence interval, 1493 is not in between those two numbers, we reject H naught, which means we can say there is sufficient evidence to suggest the mean household energy expenditure has changed. Okay. And so that's it for section 10.3 on how to do confidence intervals with the mean. Make sure you're doing your homework for these sections. And if you have any questions, you can call, text, or email me, or come to the virtual office hours.